In this lesson, you will learn how to rationalize radicals. Let's take a look at some examples to help you understand what this means. In this first problem, radical 5 divided by radical 7, the goal is to remove the radical symbol from the denominator. So you never want to leave an answer or a problem with a radical in the denominator. And there's a process we go through to remove the radicals. And our final answer will actually have the same meaning as the original. It will just look a little different. To do this, we're going to take whatever's in our denominator and create a fraction out of it that equals 1. Because multiplying by 1 doesn't change the meaning, it will just change the way it looks. So again, we're going to take what's in the denominator and we're going to create a fraction using the denominator so that it equals 1. So radical 7 divided by radical 7 equals 1. Now leaving it in this format, we're going to then multiply the numerator, so radical 5 times radical 7, which is radical 35. In the denominator, we will multiply radical 7 times radical 7, and that's radical 49. Now, if you try to simplify radical 35 using a factor tree, you will see that you cannot simplify it any further than just radical 35. So we will leave our numerator alone right now. In the denominator, however, radical 49 is a perfect square, and that changes to 7. And this is as far as we can go. 35 cannot be divided by 7 for the same reason it could not be multiplied. 35 is under the radical and 7 is not. So this would be our answer after our radical has been rationalized. Let's take a look at an additional example. So in this problem again, our goal will be to remove that radical symbol from the denominator. Now we cannot divide the 12 and the 3 because again, the 12 is not under a radical, but the 3 is. So to go through this process, we will take the denominator and create a fraction out of it so that when you divide it, it equals 1. In the numerator, when we multiply 12 times radical 3, again, we cannot multiply the 12 and the 3 because one is under a radical and the other is not. So we can simply put them next to each other. In the denominator, when we multiply radical 3 times radical 3, we get radical 9. Looking at the numerator, there's no further simplifying, so we're just going to write 12 radical 3. But in the denominator, again, radical 9 is a perfect square, so that changes into 3. Now when we're at this end process here, we always want to look and see if there's any further simplifying. Notice the 12 and the 3 are not under a radical symbol, so those numbers can be divided. So if we divide the 12 and the 3, we get 4 radical 3. In our next example, notice we have a variable in the denominator. But we still will go through the same process of rationalizing, or removing the radical symbol from the denominator. We will take the denominator and create a fraction out of it, again equaling 1. In the numerator, we can multiply what's under both radicals, but the 2 that's on the outside, we just must bring it over. When we multiply what's under the radicals, we would get radical 30x. In the denominator, when we multiply those together, we will get radical 25x squared. Now in the numerator, if you tried to simplify radical 30, you will find it cannot be simplified any further. But in the denominator, we have a perfect square. So the square root of 25 is 5, and the square root of x squared is x, because recall that for variables, taking the square root means dividing the exponent by 2. Now if we give it one last look and look at the numbers outside the radicals, notice that we cannot do any more simplifying of the 2 and the 5. So this would be our final answer. Here's another similar problem. So we will begin by creating a fraction using our denominator so that it divides to equal 1. Multiplying the numerator, we can bring the 6 over and multiply what's under the radicals, so 15 times 2x, and get 30x. In the denominator, when we multiply 2x and 2x, we get 4x squared. From here, we have 6 radical 30x over 2x once we take the square root of 4x squared. Now, taking one last look, we look at the numbers that are not under the radical, and we can see that 6 and 2 can be further simplified. So 6 divided by 2 is 3. So our numerator will now be 3 radical 30x over just x. Now notice there is an x in the numerator and then in the denominator, but because one is under the radical and one is not, we cannot cancel out those x's. So that would be our final answer. Another type of problem you may or may not see would be a problem like this. 4 over 2 minus radical 2. So this time we have in the radical a binomial. We have two terms. This is handled differently. If we actually go through, and don't do this, but if we actually go through and try to multiply the numerator and the denominator by 2 minus radical 2, which would be a similar process we've just used, you will find that the denominator will still have a radical in it, which defeats the purpose of our goal. So what we need to do instead is we're going to actually take the sign, which is a minus sign, and just simply change it to a plus. So we will still have the same thing in the numerator and the denominator, but it will actually be the opposite sign of what's separating the terms. And then you will see by doing this, we'll be able to cancel out the radicals. Now I'm going to put parentheses around the binomials because you'll see that's necessary in order to multiply. Now in the numerator, we're going to take the 4 and distribute it or multiply it to both terms. So 4 times 2 is 8, and 4 times radical 2 is 4 radical 2. In the denominator, we will have to actually FOIL 2 minus radical 2 times 2 plus radical 2. So we will take the 2 and first multiply it by 2 and then by radical 2, which would give us 4 plus 2 radical 2. Then we will take the negative radical 2 and multiply it by 2 and positive radical 2. And that will give us minus 2 radical 2 and then minus radical 4. So from here, you can see that positive 2 radical 2 and negative 2 radical 2 are like terms because they have matching numbers under the radicals. So if you add positive 2 and negative 2 together, it equals 0, so those will end up canceling, and that is how our radicals disappear in the denominator. What's going to be left is we have the 4 and then minus negative 4, or excuse me, minus radical 4. But radical 4 is a perfect square, so it's really going to be 4 minus 2, or 2. So what's left in our denominator is just 2. Now, if you notice, we have 3 outside numbers. In other words, 3 numbers outside the radical. The only way you can further simplify something like this is if all 3 numbers can be reduced by the same amount. So for example, 2 divides into all 3 numbers. So we are able to further reduce this. So our final answer would be 4 because 8 divided by 2 is 4, plus 2 radical 2 because 4 divided by 2 is 2. In the denominator, 2 divided by 2 is 1, and there's no need to put a 1 in the denominator, so we can stop and write 4 plus 2 radical 2 as our answer. Let's take a look at one more example of this. 3 plus radical 2 divided by 5 minus radical 3. So remember from the last problem, when you have a binomial or two terms in the denominator, to rationalize it, we want to rewrite the denominator but using a plus sign between the terms rather than a minus sign, because that will allow us to cancel our radicals and put parentheses around any expression with two terms. And in this case, it would be all four. So we're going to have to FOIL the numerator and FOIL the denominator. So in the numerator, we will take the 3 and multiply it by the 5 and the radical 3. And this will give us 15 plus 3 radical 3. And then we will multiply radical 2 times 5 and times radical 3. And we will get 5, I should write that in the numerator. We will get 5 radical 2. And then when we multiply the 2 and the 3 under the radicals, we will get plus radical 6. Now if you just look at the numerator, we have no like terms because the numbers under the 3 radicals are all different and none of them can be further simplified. So our numerator is just going to be a large string of terms. Now let's FOIL the denominator. We will first multiply 5 times 5 and then 5 times radical 3. So we have 25 plus 5 radical 3. And then we multiply negative radical 3 times 5 and negative radical 3 times radical 3. So negative radical 3 times 5 will be a minus 5 radical 3. And then negative radical 3 times radical 3 will be negative radical 9. So let's see if we can simplify the denominator any further. Well, we can see we have like terms, and positive 5 radical 3 minus 5 radical 3 equals 0, so that cancels, removing at least those two radicals at this point. What we have left is 25 minus, and then radical 9 is a perfect square, so it would be 25 minus 3, which equals 22. So our denominator will only have 22 in our final answer. So again, our numerator will remain the long string of terms, so 15 plus 3 radical 3 plus 5 radical 2 plus radical 6. But the denominator will simply have 22. Now if you look at all of the outside numbers in the numerator, 15, 3, and 5, and you have to look at the fourth one as well, which is a 1. And then you look at the 22 in the denominator, you cannot do any further reducing unless there is a number that divides into all 5 of those outside numbers. It has to be the same number. So if this doesn't occur, then you can do no further reducing and you are done. And that completes the lesson on rationalizing radicals.